We're working on 48. So in this problem, we need to decide which side we're going to work with first. So left or right?
Right. Well, right has formulas in it.
So here's how I decide. I ask myself, if I was going to choose that side, what would I do first? So you say you're going to choose the right-hand side. If you're going to choose the right-hand side, what would you do first?
I would switch them into the cosine.
Actually, you can't. Look very closely, and you'll see that you can't use these formulas on the right-hand side. Because this one is sine of A, cosine of A, sine of B, cosine of B. These formulas up here are sine A, cosine B, so they have flip-flop, and then cosine A, sine B, flip-flopped again. It looks like it, but it actually doesn't work. So if I choose the right-hand side, what am I going to do? And that's kind of why I lean toward choosing the left-hand side. I think it's the better one because I know for sure what I'm going to do. I'm going to immediately use the two formulas I have for tangent. Now, it's not going to be nice, it's not going to be pretty, but that's what I'm going to do. Ready? So yeah, Melon, like I agree. I think the right-hand side looks more complicated, but it's deceptive because as soon as you write it down and you ask yourself what you're going to do, you either use the formula wrong or you can't use the formulas at all. And so I choose the left-hand side. So, left-hand side. Tangent of alpha plus beta, or A plus B, over tangent of A minus B. So the first thing I'm going to do is I'm going to take this function and I'm going to rewrite it using the sum difference or addition subtraction formulas.
Oh, I was getting tested for the drugs. Stop doing drugs.
All right. Tangent of A plus B is equal to, it says. That's going to make this turn into a real big nasty fraction, but at least I know what I can do. If I choose the right-hand side, like, it looks nicer so far, but I have nothing to do. So, here we go. I get tangent of A plus B becomes tangent A plus tangent B over 1 minus tangent A, tangent B. To the top, I have rewritten using my sum difference formula. I'm do the same thing on the bottom, which is tangent A minus tangent B over 1 plus tangent A, tangent B. Now, when I get to this point, I ask myself, okay, what can I do now? Is there any way I can simplify it that looks like I could make it work very nicely? Unfortunately, there doesn't look to be much. So I'm actually going to take this function and I'm probably going to try to go and get rid of this double fraction that I've got going on. I got a fraction on top, I got a fraction on bottom. My solution doesn't have a fraction on top and bottom, so let me try to take this function and rewrite it as one big fraction. Now, I'll get nasty for a short time, but that's okay, because I'll be able to do that step using algebra. Now, I could also, a good option here would be to convert to sines and cosines, but let me tell you, if I convert this to sines and cosines right now, I end up with a fraction inside a fraction inside a fraction. If you like the movie Inception and thought it was really easy to follow, you'll like that problem. Here we go. If I take this, I rewrite it as, all right, let me annotate. So I use the sum difference, or you might write here, the addition subtraction, difference. And again, I don't do this for my notes or for my homework. I do it for my notes, but this will help explain if you look back at it later. Now I'm going to use KFC, key flip change. The top stays the same, so I get tangent A plus tangent B all over 1 minus tangent A, tangent B times. I keep the top, flip the bottom, change the multiplication. So it becomes multiplying by, I flip the bottom, so the bottom becomes 1 plus tangent A, tangent B. And then on bottom, I get tangent of A minus tangent of B. So I use KFC at this point. Apologies that my handwriting is really sloppy today. What are you talking about, Douglas? It's the same every day. Yes. Okay. Alright. At this point, like know what's about to happen. I've got two fractions being multiplied together. I'm going to multiply them together, which means I need to FOIL this thing out. My hope is that when I FOIL it out, I end up with some nicer stuff at the end. Ready? So, I'm going to FOIL. So, I take tangent of A times 1, tangent of A times tangent A tangent B. I then take tangent B times 1, I take tangent B times tangent A tangent B. I do it to the top and the bottom. Here we go. On top, tangent of A times 1 is tangent of A. Plus, tangent of A times tangent A tangent B is tangent A squared tangent B. Tangent of B times 1 is just tangent of B. Tangent of B times tangent A tangent B is tangent A tangent B squared. So I have FOILed the top, leaving me with 4 terms. Tangent of A, tangent A squared tangent B, tangent B, tangent A tangent B squared. It looks nasty now, but my hope is this will eventually simplify into something much nicer. On bottom, let's see what happens. On bottom, I take, 1 times tangent of A, 1 times negative tangent of B. I then take negative tangent A tangent B times tangent of A, negative tangent A tangent B times tangent B. And let's see what happens. 1 times tangent of A has tangent of A. Plus 1 times negative tangent of B would be negative tangent of B. Negative tangent A tangent B times tangent A would be negative tangent A squared B. Negative tangent A tangent B times negative tangent B would be plus tangent A tangent B squared. That's what I would say too. There you go. As it turns out, as weird as this is, we're actually really close to the answer. But to get to the answer, I have to do the next step, which is evil.
Sines and cosines.
I'm going to switch it to sines and cosines, combine my fractions, and simplify. And when I do, the answer pops out.
Maybe.
Ready?
If you're right.
If I do it right. Ready? Thank you for asking about it. 48 was that one. So here we go. Next step. First, any question about my FOIL? FOIL from algebra. Don't let the fact that there's a bunch of trig functions in here mess you up. It's just FOIL. First times first, outer times outer, inner times inner, last times last. Alright. I'm here. The reason I know I need to convert to sines and cosines is because my answer is only sines and cosines. That's a clear indication that's probably what I need to do. Okay? Use that fact to help guide you. That's what you have to do for these kinds of problems. They're not going to come out and say, this is the obvious thing you got to do. Sometimes they're going to be like sneaky. And you're going to be just as sneaky back at it. Okay? Here you go.
Wait,
Yes, ma'am?
never mind. I got it. I was a little confused.
Okay. You say you got it? I got it, or please don't talk to me ever again. I got it.
No, it wasn't the second one.
Okay. All right.
2 pages later, 48's done. Almost.
What can I say? Today's math is fun. Tangent of A plus tangent squared A tangent B plus tangent B plus tangent A tangent B squared.
Confused as to how we got it.
There's a lot of face problem with this.
No.
No, go ahead.
No.
I'm confused as to how we're 4 through 51, but I'm not seeing all the numbers. Like, because we had the first one that was I don't know, maybe I'm just crazy. I guess I'm just confused as to how this turned out.
Okay, you're putting it in weird order. Yeah, sorry.
That's fine.
Sorry.
Let's just.
Okay. All right. So, first one is tangent of A, so that would be sine A, cosine A, plus. Second one is tangent A squared, tangent B, so that would be sine A squared over cosine A squared times sine B over cosine B, plus tangent of B would be sine B over cosine B, plus tangent A tangent B squared would be sine A over cosine A times sine B squared cosine B squared. That's the entire top. Yay! Yay! On bottom. End up with tangent A becomes sine A over cosine A. Minus tangent B becomes minus sine B over cosine B. Minus tangent squared A tangent B becomes sine squared A over cosine squared A times sine B over cosine B plus tangent A tangent B squared, so that'd be sine A.
I should stay in there and get good.
But then you'd be doing this on your own.
You're right.
Imagine what Cole's gonna see when he walks back in this room. He sees us bored. And then he cries. And we get to point now. He's like, that wasn't so bad, just a bunch of steps. My lord. Okay.
You need to copy that.
Hey, I gotta do it too. Just be sure, take time, stretch out your hands. Break your fingers so you don't have to do the problem anymore. Total of 51. Sorry, 4 through 51. So that'd be 47. Okay, deep breath.
I'm sending this to him. So he can eat his pants.
I think she's already gone. 2 for 3 today. Egypt. Right. Okay. The last thing. The very last thing. I had to combine all of these and then the KFC again. Take a deep breath. We're going to combine all of these and then KFC again. One more time. We're going to combine all of these and then do KFC again.
Why does it feel like we should just convert the sine and cosine like way back yonder or something?
Because then when we did the FOIL, we had to FOIL with each fraction. Wait, what? Ready?
Yep, I'm ready.
Okay, this problem looks incredibly big, incredibly difficult. The steps are not difficult, it's the scale of the steps. Okay, so I'm going to ask a simple question. Don't look at the problem when you answer it. Think through it as if you were in Algebra 1 class back then it was just X and Y. Go through the glory things. Yay.
Why can't you cancel out some of the crap?
I can't cancel out until I get them in KFC. Because then I'll be able to get all this stuff canceled away. But I can't do that until it's in KFC.
It was bombing because we get sine A and a cosine A.
I know.
Sine A and a cosine A.
I know.
And that's one.
But only if I could get them to be multiples, not addition subtraction. Remember, I can't cancel addition to fraction. I gotta cancel the multiply.
What about the ones that are multiplied?
Yeah, that's the problem. Because some of them are. And that means I can't do it. Okay.
Go ahead.
If I want to use and convert these into one big fraction, they all have to have the same denominator. One more time. If I want to combine these all into one big fraction, they all have to have the same denominator. Oh boy.
No.
Oh boy.
Those are cosine A's and cosine B's.
Yep. And they're different. So it's got a cosine A and the other one's got a cosine B. I don't have the same denominator. So there is
Which number is this?
148. There's one denominator that will get all of these done. But it's a very specific one.
Cosine E squared, cosine B squared, cosine A, cosine B.
Cosine A squared, cosine B squared will get every one of these fixed.
Oh, well.
Just cosine A squared, cosine B squared. So whatever it's missing, we need to put into the problem. Okay, deep breath. Whatever it is missing, we need to put into the problem itself. So example. My long-term goal now is I want every denominator to be cosine A squared, cosine B squared. So whatever it's currently missing, I need to add into the problem by multiplication. So the big ones, that's the easiest to determine, right? This one right here, it's got the cosine B squared, it's got one of the cosine A squareds, it needs the other. This one over here, it's got the cosine A squared, it's got one of the cosine B's, it needs the other cosine B. It's the ones that are the smaller that actually have the most problems. Because it needs more pieces. Ready? One piece at a time. If you said no, I'm going to be like, guess we're going to stop for a second. And die slowly and painfully. Okay, let's start with the first term. The nice thing is once we combine these, a lot of stuff instantly cancels away.
Okay, let's go.
Okay, ready? First term. I have sine of A over cosine of A. On the denominator, I have just cosine A. I am missing three parts. Another cosine A and two of the cosine B's. So I'm going to put those in. So I'd have sine of A times. I'm missing one other cosine of A and two of the cosine B's.
I have a question.
Yes, ma'am.
This does not have anything to do with that, but
That's okay.
it has to do with another problem. Like, would cosine 7 pi over 12 be pi over 4 and pi over 3?
Yes.
Okay. That's what I just
No, there isn't. I told you 10s were the worst ones. Like, well, if I put this, it'd be like, this is the test. This one question. And you'd be like, only one question for our test? That can't be too bad. And I'd be like,
And we'd all fail. We literally all fail.
yeah, that would be terrible. I would not do that. Okay?
Mm-hmm.
Alright, let's go.
My grade's already down there.
So that was turn one. 3 more on top to go. Plus. So notice, the original pieces are still there. I still have a sine of A over cosine of A. I got sine A and cosine of A still in the problem. But the other 3 pieces I was missing to get it into this form are now in the problem.
This is not bad.
Next one. We have sine squared A. So, sine squared A times sine of B. Now the bottom has the cosine squared A, and it has one of the cosine of B's. It is missing the other. So I put one on the top and bottom. I do one cosine B on top, and another cosine B on bottom. You notice now they both have the same denominator, exactly like we need them to do if I want to combine these fractions together. I can't stress enough, we've mentioned it multiple times, when you get to higher level math stuff, the problems get to be very complex like this. What you have to do is look at it one piece at a time. If you look at the big problem, it is scary, it is intimidating, you will cry. look at the big problem, and instead say, no, I'm doing this one part, I'm going to follow the rule for this one part, and then okay, boom, reset. Next part, do the same thing. Next part, do the same thing. One piece at a time. Okay?
This is bad. I only have enough room on like one length of my paper to do this whole top part of the fraction.
That's how you know it's getting good.
Like,
how you know it's getting
do I go back to
real
the
good.
bottom, or do I like go to the other page?
Okay, so I've done this first piece. I've done piece number 2. I need to do piece number 3. So what's it got? It has sine of b and 1 of the cosine of b. It needs 1 more cosine b
And a cosine squared.
and a cosine squared of a. So cosine squared of a, cosine squared of a. So it originally was sine of b over cosine of b. I still have sine of b over cosine of b, but it was missing 1 cosine b and 2 cosine of a's.
Next one's the same thing.
Next one's very similar. Yes. Here we go. Plus. All right. Last one. Okay, so it already has a cosine of a and a cosine squared of b. It is missing 1 of the cosine of a's. So the top has sine a, sine squared of b. The bottom has cosine of a, cosine squared of b. It is missing 1 of the cosine of a's. So I do cosine of a on top and put the other one on bottom. Now, every term on the top has cosine squared of a and sine and cosine squared of b.
Can I do the bottom?
I have the same for the bottom. Now, once we get that piece done, I will show you how people like me do math a little faster than people that don't. Because everything on the bottom is going to be the same, right? It's going to be the same for both of them, right? Remember, if it's in the same place on both the top and the bottom, they can cancel, right? Literally everything on the bottoms of all of these will be the exact same. So everything on the bottom for all of these will all cancel. I just have to convert them first. I can't cancel until every denominator is the same. Top's good? Let's go bottom. First one. What's missing? Well, it's got a cosine of a. It is missing 1 more cosine of a and 2 of these cosine of b's. So the first one becomes sine a times. So it's missing 1 cosine of a, so cosine of a, and both cosine b's, so cosine b squared. Now the bottom is correct. Again, it's still sine a over cosine a. We had to put in 1 more cosine of a and 2 cosine of b's to get it to match all the other ones. Yes. If all of the denominators are the same, they can cancel away. Remember, in algebra, you can cancel something if it's in everything. You can cancel something if it's in everything. If I have it in everything in the top and everything in the bottom, I can cancel it away. Plus. Now done. Oh, sorry. Minus. Sine b over cosine b. It is missing, once again, 3 things.
I think so.
Turn around and walk out.
Oh, seriously, we've been doing one problem for the past like I don't know,
This is
20
the
minutes.
problem we're working on.
The whole class had was just doing this one
The
problem.
homework. Here, there's been like 20 different fractions.
I could have skipped all week.
I should have.
Then you have to do it next week. While we're doing new stuff.
That's true. You need even more homework. When is this due again?
Tomorrow.
Tomorrow, like at like 12.
Midnight, yeah. Alright.
Technically not tomorrow.
One more piece of time. Negative sine b cosine b. It's missing 3 things. It is missing 1 more cosine of b and 2 of the cosine of a's. Let's do it. Minus. So we have sine b on top. 1 of the cosine b is already on the bottom. So I put one more cosine b to make it cosine b squared, and I need two of these cosine a's. Thankfully, these last two are the easy ones. You're only missing one thing each. Okay? So this first one, it's got cosine squared of a. It's got one of the cosine of b's. It is missing another cosine of b. So I'll put that in. Minus, I still have sine squared a. I still have sine b. On the bottom, I still have cosine of a squared. And I have one cosine of b. So I put one more in on the top and the bottom. Now everything matches. Plus, last one.
That wasn't necessary.
That was definitely not. And then I was walking down the hallway.
Wait, plus.
Last one. Okay, it's got one of the cosine of a's. It's got both cosine b's already. So it needs one more cosine of a to be finished. Here we go. It's got sine of a. It's got sine squared b. Needs one more cosine of a. Make the entire bottoms cosine squared a, cosine squared b. Why would we do that? Why? Why, God, why? Why have you forsaken me?
I can even like look at that and like understand what like matches.
One piece at a time. If you look at this as a big problem, it will make a grown man weep. You gotta look at it one piece at a time and say, did I do what I need to do for that first piece? Yes. Did I do what I need to do for the second piece? Yes. So why the big long step? Because all the denominators are the same. All the denominators on the top, all the denominators on the bottom. Guess what? If it's the same in the top and the bottom, it cancels. Which means gone, 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 gone. All that's left is the tops. What you'll notice is a bunch of sine b's, cosine b's, all in one fraction, which is what the answer looks like. This is dangerously close to being done. We are on the last step. All we got to do now is figure out the final step to get to the solution. Here we go.
Problem was to do in the first place.
My original problem was I want to get it to look like this, which notice has a fewer pieces, right? Much fewer pieces. I am close. Everything's in terms of sine and cosine, which is what I want. I just got to figure out what tiny thing is missing from this problem. So I scroll down. I go back to it. Here we are. Okay, I'm going to rewrite, just because it'll make it look cleaner. It's not necessary, but I'm going to go and rewrite it. Equals. Okay, all the denominators are gone. So the first one is sine A, cosine A, cosine squared B, plus sine squared A, sine B, cosine B, plus sine B, cosine B,
Okay, come on.
cosine squared A, plus
Jeez.
sine A, sine squared B, cosine of A. That's the entire top.
No shot. No shot.
Make money. Big money. Come on.
Jeez.
The bottom,
Close your mouth.
sine A, cosine squared B, minus sine B,
Oh
Cosine B.
my god.
cosine squared A, minus sine squared A, sine B, cosine B, plus sine A, sine squared B.
I think I'm going to die.
I somewhat understand it though now.
It's weird, right?
Yeah. This is gross. This is
Yeah, it's gross. Welcome to that, baby. Come on. Okay, I could do this again next block, so I don't want to hear it. Don't do that to me. Okay. Fun facts. The answer's right here.
Fun
Just
fact,
figure
yeah,
out
that's
how.
a fat, that's fun.
If we can just figure out how. The answer's here. Say again? Actually, we can. There are things we can combine together.
There's so much I can't read my own handwriting, so I don't know what's in it.
Exactly.
Oh my gosh, I can relate.
Yep. Okay. Take a deep breath. The final step. A bunch of those factors.
Like factors?
Factors. Take a deep breath.
Like what do you mean by factor?
What I mean is.
Like if you make me AC method a trig function, I might like just leave.
No. No, none of that. A bunch of it factors and disappears because of a Pythagorean identity. One more time, take a deep breath, okay? We're at the end. You are lap 4 of the mile run. You have the last 100 meters to go here. Okay? We're almost there.
This is why I don't run in track.
Sorry, man. We're in the last set of the spin. You float it now, you'll break something.
This spin don't take this long.
Okay, ready? What I want to point out here is, if you look at this problem, we have sine A cosine A. Cosine B squared. Over here we have sine A cosine A. Sine squared B. Those two pieces factor. One more time. Look at those two pieces underlined. They both contain sine of A. They both contain sine of B, plus one more thing. And that one more thing should look very familiar. One of them is sine squared. The other is cosine squared. And sine squared and cosine squared cancel. Last step. Here we go.
I'm gonna write mine and put this on the high schoolers math on there. Not even you, whoever made the book.
It's a good time, right?
Either I'm just really dumb or people from other schools are lost hard.
No, this is a tough problem. This is meant to be a challenge level problem. Each homework assignment, by the way, there's usually one even level problem that's supposed to be like, if you can do this, you have mastered everything in that chapter.
Is this that problem?
This is the problem. No? That's why I gave an entire class period today to answer questions.
You know, you answer one question, hold it.
Possibly. We've got 10 minutes left to see if we can finish it. Alright, ready? Ready?
The score.
This first one. So, one more time. We got sine A, cosine A, and then a bunch of other stuff. We got sine A, cosine A, and a bunch of other stuff. What I will do now, I will combine these together with factoring. I will take a sine A out of both of them, a sine B out of both of them, sorry, a sine A and a cosine A out of both of them, leaving something behind in each one. This first one equals sine A, cosine A, times. If I factor out a sine A and a cosine A, what's left behind is cosine squared B from this term, plus sine squared B from that term. Look at the two terms in blue. They factor that term. I factor a sine A out of both those terms. I factor a cosine A out of both those terms. What's left behind? Cosine squared B and sine squared B. The second two terms up here now underlined in green. Do the same thing with different pieces. Both of them contain a sine of B. Both of them contain a cosine of B. And something else. So let's factor them. Plus, both of them contain sine B, cosine B. What's left behind from each one? Well, this one has sine squared A. And this one has cosine squared A. On bottom. Same thing. Two of the terms have something in common. Wait, where did everything else go now? Someone's missing which stuff. Oh, it keeps erasing stuff. This one was sine squared A, sine squared B, cosine A. There we go.
Wait, sine squared it?
Sorry, sine A, sine squared B, cosine A. All right, the bottom. Let's see. In red, sine A, cosine A. And over here, sine A, cosine A. Those red ones, factor. What's left behind? Well, I take out a sine A, cosine A. Come on. Come on. Please. We're so close.
It's just, even the board's
You have
giving
so
up.
much written that it can't.
It knows. It's like, please, sir, no
Your
more.
next trig class, you shouldn't explain this problem, just show it to them. You scroll down and tell them to figure it out. See what they say.
But video it and post it so we can see it. The reaction.
I can make some nice memes out of this problem. All right. So I factored sine and cosine out of both those terms. And what's left behind? Cosine squared B, sine squared of B. The other ones. First, they are both negative. So I'll factor a negative out. They both contain sine of B and cosine of B. And what's left behind are two things. Here we go. It's really not like that now. All right. Minus. Do I want to close it? No, I don't. Not again. Not even a little bit. Minus. All right, I take a sine of A out. I take a cosine of, sine of B out. I take a cosine of B out. And what's left behind? Cosine squared A plus sine squared A. I want to point out here that I didn't choose this at random. Look at everything outside of these parentheses. It matches the solution I'm supposed to get. I'm supposed to get sine A cosine A plus sine B cosine B. I'm supposed to get sine A cosine A minus sine A cosine B. I'm matching my solution. I'm doing step 3. It's just doing it in a weird way. I had to factor this thing, which is on my list, but you never thought you'd do it this way. All right, last step. On that cheat sheet, Jacqueline, in front of you, sine A and cosine A squared are equal to what? Sine squared plus cosine squared. 1. So this entire thing is 1. This thing is 1. All 4 of those parentheses are just 1, and I'm left with the solution. This thing, 1. This thing, 1. All that's left behind is the answer. Sine A, cosine A, plus sine B, cosine B, all over sine A, cosine A, minus sine B, cosine B. We're done.
Literally a
We
full
did all
page.
that for that.
All that for one problem? You guys are getting ready for college. Woo! Welcome to being a math major. Suggested if you love it.
Hey, will you come here, please?
Yes, sir. Alright, before I do, I would never expect anybody in this class to do this on their own. Okay, this is meant to be a mastery level problem. When I say mastery, I don't mean like, I got an A in the class. No. This is like you should be teaching it. This is the level of mastery that it means. If you can do this on your own, you should be up here and I get to sit in the back doing nothing. I don't expect it at all. I want you to try it, see as far as you get, and when you get to a spot where it's like, it's not making any sense anymore, I'm here. I'm here to help out. Okay? That's why we have it. This is an advanced level problem. I would expect no high school student to be able to do this. At the same time, note that everything we did was an algebra 1 problem or an algebra 2 problem just with trig equations. Factoring, that's an algebra 1 problem. Combining fractions, that's pre-algebra. But doing it with these parts makes it college level math. That's it. Take a deep breath, guys. You did something only a few people in this high school can do. Congratulations.
What, copy down what the teacher writes on the board?
Adam couldn't even do that. You kidding? Let's go.
Chris Pavoni, you're needed in the office. Chris Pavoni, you're needed in the office.
Yeah, I didn't copy any of it down, so I'm just trying to do it. And
Just take it one step at a time.
yeah, I don't think I can do it.
Okay, I want to point out here, you thought it was bad in the moments. Look back at it now. Now that we've gotten to the end, we've taken that deep breath. Like, look at all the work we had to do. Okay? It sounds simple when you put it in words, but physically doing it is not easy because it's a difficult problem. Take a look from the very beginning. From the beginning. The first thing we did was rewrite using our formulas. That's trig. That was the only trig in this problem, by the way. This was it. That's it. From there, we FOILed. That's algebra 1. We converted things to sine and cosine. I guess that's a trig concept, but we also talk about it in geometry. We combined fractions. That's an algebra 1 and pre-algebra concept. We factored. That's an algebra 1 concept. And we got down to here as our final solution using a trig identity, the only other trig step in this problem. 3 trig steps, 3 algebra steps, and every single one of them, the algebra step was the hard thing. The trig step was pull the formula out and use it. That's what makes upper level math hard. Because everything else gets applied when it gets deeper. Good times. Thank you for asking about 48. I'm glad somebody did. 22? Much easier. In that case, I use a calculator to find the inverses and then plug in the sine function or cosine function respectively. Other questions? Cole, you said you had a question, but then you said it yourself. So.
Yeah, he's kind of delusional.
Shut up.
Hey, what's the,
Oh yeah, I have a question.
what's on the
Enjoy the rest of your day.
So on this, what would be
Can I still do it? Can I still do it?
In this case, this one or this one? This one. So I have sine of 2x cosine of 5x minus sine 5x cosine of 2x. So what I want to point out there is that matches this function.
yeah.
Okay?
Is that on
This? It's on your teacher.
Okay, I got it now.
Okay?
Yeah.
Woo! How does it feel? You know what I like? Is that cathartic feeling
No
after?
shot.
You're like, it's done.
Jeez.
It's over. Here's the Lord of the Rings.
It's
done.
No, I can easily slip my hand. Where at?
Take it back.
Swing.
Sure. There's nothing for us.
I got a question. Did you take
Oh, yeah.
on that problem? Could you take different steps and get the same answer?
Yes.
But like still stay on the same side, but just take slightly
Yes.
different. Okay.
Yeah.
Good.
Where's that?
Because mine was nothing like yours. Because I
You can.
took some stuff out halfway through.
Yeah, you can.
Okay, good.
So you can't cancel stuff out halfway through.
You can't cancel it, but you can rewrite it using a different algebra step or a different trig
Put
step.
it in the go.
Oh, I hate everything.
Hey, everything's bad for health, man.
Well, you guess I'll die.
Her friend.
I'll fall over and croak.
Allison, she really did it.
I'll be honest, whenever I do it, I use a different order. I did the first KFC step same as they did. And then in that KFC step, I don't FOIL it out until I fix all the division problems. It makes the problem about half as long. But it's really hard, really complicated. You've got to cancel correctly, otherwise you get a bunch of crap at the end.
God, she's so
Basically, those middle 3 steps
She
go
is
away.
out of it.
She's a dog.
Quit, you're getting my mask dirty, knothead.
Can I?
Say, shut up. Hey, remember face
I'm
on
not.
me.
I'm not getting you.
Yes, you are. I'm starving.
No.
Selfish. Douglas, I sat in that I sat in that room for 2.5 hours.
Wow. That's sad.
I hate it.
Why don't you just go?
I couldn't because when I get here, I go to the bathroom and I take a shower, and then after that
Go, man.
I can't. I drank 4 things of water like that, and then I finally.
Crazy, man.